Hello, my name is Rob Reynolds. Welcome to College Algebra, Chapter 3, Section 3, Systems of Linear Equations. Today we're going to be looking at determinants. We're going to start with a simple determinant, a 2 by 2 determinant. I call it the peanut minus the hot dog lesson. This kind of looks like a peanut, but it's this diagonal minus that diagonal. So the definition is AD minus CB. So an example of this would be negative 2 times negative 1, which is 2, minus 12, negative 10. If it's a 3 by 3, you can rewrite column 1 and column 2 here. 2, negative 2, 0. Negative 1, 5, 6, and I'll still do peanut minus hot dogs. But this time I've got three peanuts. So the first diagonal, 10 times negative 9, negative 90 plus 0 minus 36. And then I'm going to subtract off all of these hot dogs. So that's a 0. That's 12, and then the last one would be 18, negative 18 actually, so 0 plus 12 minus 18. So doing a quick little number crunch here, I'm coming up with negative 120. We can check this on our calculator by going under second matrix. Let's try that again. Second matrix. I'll edit this as a 3 by 3 matrix. Entering each point. Put under, I'll do second quit just to pop out of that. Go back into second matrix, go to math. And the very first one, number 1, is determinants. So second matrix, shoot, I'm going to delete that. Sorry, second matrix, pull up determinant of matrix A, and there I verified negative 120. You can also do it through the cofactor method. This is useful. If one of these is an x or a y or a variable, you can no longer do it on the calculator. I'll show you an example in a minute. So we do need to learn about cofactors. And the cofactor is just kind of a minor matrix of the larger matrix. If you're going to expand across row 1, notice I'm taking the elements. So there's the first element, there's the second element, and there's the third element. But if I take the very first element, it's kind of like wiping out this row, and what's left is this cofactor right here. Notice it goes times this. And then I would do the determinant, peanut minus hot dog, of that cofactor, or that's called the minor matrix. So I'll back up here a little bit. You can see I've highlighted this in yellow for you, and the yellow represents the second row 1, column 2. So if you wipe out row 1, column 2, you can see I've got these blue colors and then the green colors for the minor matrix, and then I would go ahead and find that cofactor. So if you add 1 and 1, which means row 1, column 1, if you add that, that's an even, so that makes this a positive. If your rows and column add up to be odd, then it's negative. And if your rows and column add up to be even, it's back to positive. So this is called minor matrix. Eliminate row 1 and column 3, and you can see what's left is this minor matrix, which I find the determinant of that. So an example of this would be find the minor matrix for row 1, column 2. So I would just eliminate row 1 and column 2. And the minor matrix that I have left is negative 2, 1, 0, negative 9. I could find the determinant of that. If I do the minor for 2, 3, I would eliminate row 2 and 3, and I'd be left with 2, negative 1, 0, 6. So an example of this is just explaining whether it's positive or negative, depending on whether the row and the columns add up to an even number or an odd number. And then this is just the minor matrix for the definition. Again, another example. So if it says expand across row 1, I'm going to use this is row 1, column 1. So if I know it's a positive 3 times its minor matrix. So I'm going to eliminate the row 1 and column 1. We move with 6, 2, negative 2, 3. Then I'll move on to expanding across row 1. So I'm going to grab the 0 next. After the 3 comes the 0. So by the way, it's a minus 0. It's not going to matter because 0 times any determinant. But if I were to eliminate this, I'm left with 4, 2, 8, and 3. Eliminating row 2 and row 1, column 2. And then I would say plus this guy, which is a negative 1. A little bit confusing. I should have just said minus 1. But eliminating row 1 and column 3, I'm left with the 4, 6, 8, negative 2. So this is an alternative method. Instead of creating column 4 and column 5 being the 3, 4, 8 like I showed you before, and the 0, 6, negative 2, and doing all of the peanut minus hot dogs, I'll get the same answer if I do that. But again, you're thinking, well, if I use numbers, I might as well just use my calculator. But my next example, I'm going to use variables. So just finishing this up, 3 times the quantity, it's peanut minus the hot dog, but it's minus a negative 4. This is just going to be 0 minus 1 minus 48. If we number crunch this, we'll get 122. And again, the author says the answer is 122. Now, we could have expanded down row 2 just as easily. I'd end up with the same answer. The reason why I'm going either across row 1 or down column 2 is because I like that 0. It's going to wipe out one of my matrices. So again, same thing for this one. I'm using all numbers, so honestly, I would probably just use a calculator. Here's an example where you cannot use a calculator because I have a variable in here. So this is where you'll probably have to do this by hand. So I'm going to expand across row 1. T times the, by the way, that's row 1, column 1, so it's positive. 4, 3, 3, 3, if I eliminate row 1, column 1, minus 1 times its determinant, negative 6, 3, and then plus 1, that last one, eliminate its row and column, and I'm left with negative 6, 4, negative 1, and 3. And I know that this is equal to negative 2. So this is 12 minus 9. So 3t minus 1 times this negative 18 minus 3 plus 1 times negative 18 plus 4 equals negative 2. So 3t plus 15 minus 14 equals negative 2. 3t equals negative 3, t equals negative 1. And the author ends up with the same. Trying it one more time. Direction says expand across row 2. So this is row 2, column 1. So if I add the 2 and the 1, that's a negative number. So I would start with negative 6 times its determinant plus x times its determinant plus 0 times its determinant. Grabbing the 6, the x, and the 0 expanding across row 2. The minor, let's see, if I eliminate this row 1, column 2, I'm left with the 3, 2, 1, negative 2. If I eliminate across 2, I'm left with x, 2, 3, negative 2. And if I eliminate for the 0, which doesn't really matter what goes in here, no matter what I put in there, it's good, but I'll do it. It's the x3, 3, 1. So finding the determinant, negative 6 minus 2 plus x times negative 2x minus 6 plus 0 equals 48. So this becomes 48 minus 2x squared minus 6x equals 48. Subtracting off of 48, negative 2x squared minus 6x equals 0. I'll factor out a negative 2x, leave me with positive x plus 3, and set each factor equals 0. This equals 0. When x is 0, this equals 0 at negative 3. And it looks like the author gets the same answers. Might have done just a little bit different method. Again, you can check the PDF files on Blackboard. A couple things about determinants, some properties. If you swap row 2 with row 1, notice the answer changes from positive to negative. So swapping rows will change the sign. If any two rows are the exact same, the determinant will be 0. If you multiply by some k factor by some row, so I'll factor out this k, and you can see all I'm doing is multiplying row 1 by some k factor. The determinant is actually unchanged. It's multiplied by that. So if the determinant was negative 2 before, now it's just going to be that constant k times the negative 2. So if that constant's a 5, this answer would be negative 10. And then if you do any row operations with it, for example, if you do negative 2 times row 2 and add it back to row 1, the determinant is unchanged. So several properties that you probably want to take a look at and be familiar with. If you don't recognize them, you'll just work the problem as normal. I hope this video was helpful. Please email me with your questions. Thanks.